Understand the relationship between chemical formula and oxygen content. Each of the given metal oxides, Na2O, MgO, K2O, and ChO, contains exactly 1 mole of oxygen atoms per mole of the formula unit. State the mathematical expression for the mass of oxygen in a sample. For a 1.00 gram sample of any of these compounds, the moles of the compound present is calculated by moles of compound equals 1.00 grams over molar mass of compound, because there is a 1-to-1 molar ratio between the compound and the oxygen atoms. The moles of oxygen atoms is also equal to 1.00 grams over molar mass of compound. Thus, the mass of oxygen in a 1.00 gram sample is mass of O equals 1.00 grams over molar mass of compound times 16.0 grams moles to the power minus 1. Identify the underlying chemistry concept. Percent composition. This question tests the concept of percent composition by mass. The mass of oxygen in a 1.00 gram sample is directly proportional to the mass fraction of oxygen in the compound, 16.0 grams per mole over molar mass. Therefore, the compound with the lowest overall molar mass will have the highest mass fraction of oxygen, meaning its 1.00 gram sample will contain the greatest absolute mass of oxygen. Compare the molar masses from the provided table. From the exam's reference table, Na2O, 62.0 grams moles to the power minus 1 MgO, 40.3 grams moles to the power minus 1 Kelvin 2O, 94.2 grams moles to the power minus 1 ChO, 56.1 grams moles to the power minus 1. Select the correct compound. Since MgO has the lowest molar mass, 40.3 grams moles to the power minus 1, it has the largest proportion of oxygen by mass, 16.0 over 40.3, approximately 39.7%. A 1.00 gram sample of MgO will therefore contain the greatest mass of oxygen, approximately 0.40 grams. Confirming option B is correct. The correct answer is option B, MgO.